Welcome to the IMSAI channel, where I try to resurrect an old IMSAI 8080 computer. Alright, I thought I'd show you a little closer up with this wonderful Sony magic in here. Alright, so I thought what we'd do is we'd take a look at the power supply and take a look at the batteries. Maybe I can resurrect the battery pack and get this thing operational again. All right, let's. I think we can get to it from this side. There's quite a few screws in it, though. Wow, they are in tight. Oh no, I hate this. Definitely have a lot of screws. Like I said, this thing really feels like military grade. Got one strip screw here. Oh man, that was just not coming out. It's the last one, so maybe I can just rotate it. There we go. Awesome. Maybe find a replacement screw for that one. All right. Make sure we don't lose all these little screws. Get that back on the frame. Little piece of foam. It just feels like regular foam. There we go. There are the batteries. Oh, and they're crusty too. That's why I wanted to get them out of there. Looks like Nike had crud. I wonder if they come out of there or not. Let's see if I can turn it upside down. Oh, wonderful white powder comes out. And I wonder if they are attached to this side anyway. Looking for solder connections to the battery underneath, but I don't see any. We might have to disassemble further. Let's see if I can grab that battery, pull it out. I moved a little bit. I don't think there's any charge on it. Yeah, it's moving, but I don't know how it's connected, so I think we need to get out a couple more screws. Why not? Let's do that one. Oh, this screw's a little bit longer, so I'll keep those separated. Oh, this is a little longer. All right. There we go. Let's see the batteries there. And they're on wires, so I think we can pull them out. Yep, I see them. Red wire and a green wire. There we go. Farther. Wow. Wires are in there tight. They go through a hole up to the top. Yeah, they're there. One wire there, one wire there. Red and green. I'm assuming ground and 5. Alright, let me cut these out of there. The red one. Just make sure I mark these. Red goes there, green goes there. I just want to make sure the polarity was plus and minus. Yeah. Alright. I have a little foam pad for over here. Okay, so I should be able to get a NiCad pack like that somewhere. Get this thing working again. I think they claimed about 4 hours of use on a charge. Well, that's pretty good. For grins, let me measure the voltage of these batteries. Expecting 0. Yep. Dead. Alright. So, let's see if there's anything else interesting in here. There's a, like I said, this little AC connector. And there's a little, the fuse is in here in a little compartment, but it's a little broken connection. Oh well, I don't think it really matters, but fuse has got a little plastic shroud over it so it doesn't short out on anything. And there we go. Smooth in there. So this is a little shroud that went on it. And this was part of this plastic piece. It looks like phenolic. Looks like very old plastic, and this is broken. So I think I will glue that back together. Yeah. All the wires are all bent at right angles very nicely. Japanese ladies. Yeah, I'll put some black epoxy to put that back together and search around for some battery packs. That'd be pretty cool. Alright, so wait for some parts in the mail. Okay, I just had to show you this. This is a little, this is for the, what is it, horizontal, and when you pull on it, it actually slides the entire pot assembly, and there's a little slide switch over here, and it makes that slide switch actuate. It's just hilarious. And there's another one over here. Amazing. I don't know how much thought went into that. That's crazy. Alright, so I ordered some batteries to build up a new battery pack. I ordered some nickel metal hydrides. This had nickel cadmium, and the cadmium batteries don't have as much capacity, and they leak, and they kind of bleed their charge off and stuff. The nickel metal hydrides are just a better, newer technology. I went ahead and ordered some 2/3 Cs, which will be a little bit smaller, but they have the same current capability that the batteries that were in here had. So I've added some wires to these little short wires that were down there, so I'm ready to go. We have the AC input here. I glued back the little PC board here that has the fuse on it. There's a little cover. Here it is. There's this little plastic cover that goes over this. We can put that back on. That protects that fuse from shorting out anywhere. Okay, so actually I found the schematic for this. It's the same as the model 323, which is a little bit slower, but same thing. And if you can see it all here, but let's see, adjust the focus a little bit. There we go. All right, so let's just start up here. We have the AC coming in through the fuse. It is switchable. There's a transformer that then supplies 2 voltages. There's a bridge rectifier that supplies the main voltage, which is really what we care about. Here's the battery pack that we're replacing. So the battery pack goes through this 0.3 ohm resistor and a PNP transistor, and that's the charging circuit. So we're going to charge through this circuit. So there's a negative voltage here. That's how it charges. Is it goes below ground on this side, so it charges with a negative voltage to the negative terminal. This is a high current transistor. In fact, it's the one here on the outside, a little TO. I'm not sure what those are called. It's not a TO3. It's smaller than a TO3, but it looks like a TO3. It's a tiny version. So the charge current of when you're charging the battery is monitored across that 0.3 ohm resistor. It's done so with basically an op amp. This 2 transistor diff amp here acts like an op amp, and so it sets the voltage here, and it's basically a current mirror to whatever you have set over here. And there's a potentiometer on this side that allows you to set the charge current through the device, and you can see that here there's a little potentiometer, so that's how you set the charge current. So this should be straightforward to work on if it acts like it's not working to charge the battery, but it probably will. Here's where we input the external DC, so we can either use the batteries, we can use an external, or we can use the internal, and so the internal can run straight out. So this is where the voltage goes out to the rest of the oscilloscope. So you have a choice of using the battery or using the AC. So it looks pretty straightforward, and like I said, I should be getting the batteries in fairly soon. We can put this all back together and see if we can power the oscilloscope up with with battery powered. That'd be really nice. Maybe the only battery powered scope I have. So we'll try that out. Alright, I found some problems. Let's see if I can focus on it. That's good. So when I rotated the knob for the trigger circuit, it didn't seem to be working. Only the auto settings seemed to be working, but not the manual trigger. And that's due to a problem right in here. There's a potentiometer here, and the knob, when you rotate it, there's some switches. So it works in the two switch settings, but in between it should be rotating this potentiometer. And there's a shaft coupler here, and that shaft coupler is broken. So we need to... It's kind of in the way there. Anyway, there's a metal collar that's supposed to go over these and two set screws, actually four set screws. Set screw from the top, set screw from the bottom on both sides. And those are broken, and so now the thing just free spins. So in order to fix this, I could make new collars, but it would require me a disassembly almost the entire oscilloscope, and I just don't feel like doing that. So what I'm going to do is I'm going to drill through this bushing and put a pin in it and glue this side onto that pin. So this side will be fixed solid. And then on this side there's a flat in the shaft, and I'll rotate it so that they're the right engagement phase, and then I'll put in some epoxy glue into that hole there, and hopefully I'll wet onto that flat spot and bind the other side up. And I think that'll work. I think that'll work fine. There's another one of these that happens the exact same way. The coupler is broken, and that was the vertical uncalibrate knob, which I said was feeling like a 10-turn pot. Well, that's just because there wasn't a hard connection between the two. It should be a single-turn pot, but it needed you just to, by friction, try to get that potentiometer around and around and around. Let me show you why these things are the way they are. I'll bring in the bits and pieces here, and let me see if I can focus on those. There we go. So you can see that there were these little collars that went around the plastic piece. Let's see if I can put one kind of together here. They'd look something like that, and there'd be a screw from one side and a screw from the other side. And these were very, very lightweight aluminum, and they've just cracked. Just bad casting. They're cast parts. They weren't machine parts. They're cast parts, and maybe they were even plastic. I mean, they look like they're aluminum. They're just very, very poor casting, and they just finally stressed and cracked. So instead of remaking those and putting them in, I'm just going to do that glue trick and see if I can't get them to work. I mean, I don't want to spend a lot of money on this scope. It's not worth that much. So that should get it going. Okay, so I've taken a drill, pretty small little drill, and basically the shaft on the potentiometer was brass, so it was easy to drill into. So I put a divot in the shaft from this, and now there's a cup where the set screw used to be, and I filled that with a dab of epoxy. So now there's a plug of epoxy that seals in the hole of the shaft coupler and goes into a divot into the brass. And so if I rotate it, now you can't see it, but the shaft rotates as well. So now I have to let it dry, cure all the way. And then I'm going to phase these two, and in this hole over here, I won't need to drill into that one because there's already a flat on this shaft. So hopefully the glue will bind onto that flat and cause it not to rotate. So I could go in and drill it if I need to, but I think that's a steel shaft on this side, so that'll be a little harder to drill into. So we'll let that dry and see if we can't make that work. And if it works over here, I'll flip it over and do the other one, which would be almost an identical job. All right, here's the test. So now you can see that we're rotating both, and things work great. All right, I'll do it with the next one, and that should be it. All right, here's the other one. You can see now that it's glued, it's turning good also. So fix those two problems. We just have to wait for the batteries.